So beginning with triangle ABC wants to do a dilation with a scale factor of 2. So to do that construction, we'll begin by constructing ray AB and also by constructing ray AC. And next, I want to mark off, since we're doubling AB, let me find the length corresponding to AB. And now positioning my stylus at B, we mark off that distance, constructing point D. Next, we'll open our compass to AC. Setting our stylus at C, we construct the next intersection. Call that E. And so we can then use a straight edge to construct segment DE. Now what do we want to show? We want to show two things. So the first thing we want to show is that BC, segment BC is parallel to segment DE. And the second thing we want to show is that DE, the measure of DE, is equal to 2 times the measure of BC. And so we'll begin by looking at the construction to see what we already have. And I know that AB is congruent to DB. And that's true by construction. Those are the same because we made them the same. So same thing for AC and EC. So AC is congruent to EC. Now without using triangle similarity, I'm going to have to use triangle congruence. And so looking to see what we have, this segment BC is congruent to itself, and that's by the reflexive property. And so the strategy that I want to take is to construct a parallelogram and use the properties of parallelograms to help me show congruent triangles. So with my compass still set at AC, I'm going to move the stylus down to B and sweep an arc that intersects line segment DE. Now likewise, I'm going to change my setting to AB and sweeping this arc. The point is concurrent, and we'll call that M. And now we can construct segment BM and segment CM. What do we know? Well, we know that AC is congruent to MB, again by construction. And we know that AB is congruent to MC, again by construction. Now, triangle ABC is congruent to triangle MCB by side-side-side congruence. And this means that angle ABC is congruent to angle MCB because corresponding parts of congruent triangles are congruent. Further, we have that angle ACB is congruent to angle MBC, again because corresponding parts of congruent triangles are. Now, the measure of angle BAC, this angle, is equal to 180 minus the measure of angle ABC minus the measure of angle ACB, and that's true because of the triangle sum theorem. From the definition of a straight angle, it follows that measure of angle DBM is equal to 180 degrees minus the measure of angle ABC minus the measure of angle CBM. And as we've already shown, angle ACB is congruent to angle MBC or CBM. And so therefore, measure of angle BAC is equal to the measure of angle DBM by the transitive property. And so therefore, angle BAC is congruent to angle DBM by the definition of congruence. So we've just shown that these two angles are congruent And so we can now make the argument triangle DBN is congruent to triangle AC by side angle side. Angle BDM is congruent to angle ABC by corresponding parts of congruent triangles. Therefore, BC is parallel to DE. Now, since we've proven these lines are parallel, it follows that CM is a transversal by definition for parallel lines BC and DE. And so we have that alternate interior angles are congruent. So we have angle BCM is congruent to angle CME, alternate interior angles. The measure of angle AD is equal to 180 minus the measure of angle ADE minus the measure of angle D. Well, let's call that actually BAC. And that's triangle sum theorem. Now if we look here, I can see that I have two of the three angles for another straight angle. And so we can say that measure of angle BCN is equal to 180 minus measure of angle ACB minus the measure of angle MCB. Again, that's the definition of a straight angle. So measure of angle ECM equals the measure of angle BAC by the transitive property. We now have that triangle ABC is congruent to triangle CME, again by side angle side. And once again, ME is congruent to BC. Corresponding parts of congruent triangles are congruent. And once again, DM is congruent to BC. Corresponding parts of congruent triangles are congruent. And so the measure DE is equal to 2 times the measure, I don't need to put it in. DE is equal to 2 times the measure of BC. So we've proven that BC is parallel to DE, and that DE is twice the measure of BC.